Okay, so here's the final video review for our grade 12 college math class. This one is on personal finance, focusing mainly on annuities and mortgages, but also looking at a little bit of savings, long-term savings in a bank account. Um, you'll notice a bunch of these questions have the TVM solver um, like variables included in them. So I'm going to be recording those values. Unfortunately, the screen recorder that I'm using won't let me, it will only let me record my slide screen and not the TVM. So I'll be showing the numbers that I have typed into the TVM solver, but I can't actually show you that website at the same time. So my apologies for that. I would encourage you to open up that TVM solver link, TVM solver, that is posted on the right side of our course homepage. There's a link to it there, and you can like type in exactly what you see me writing to try it out yourself and see that it's working okay for you. Okay, so question one. Two friends, Hannah and Reese, plan on going to college in 2 years. Hannah makes monthly deposits of $100 into an account that pays 4% compounded monthly. Reese makes quarterly deposits of $300 into an account that's also 4% that compounds quarterly. How much does each person have after 2 years? So we're going to do kind of a side-by-side comparison of their savings. So we're talking about two scenarios, both of them having 4% interest. So I'm going to start there. They're both starting with nothing in the bank. So the present value for each of them is 0. It doesn't tell us anything about a starting balance. Hannah is making deposits of, or payments of $100. So she's giving away $100 every month. Reese is paying $300 each time. We don't know how much they're going to have in the future. That's what the goal of this question is. So I'm going to put a question mark in those two spots. And then we have to look for the details about the paying and the compounding. So Hannah is making monthly deposits, so 12 per year, into an account that pays interest compounded also monthly. And with that, we can go back to the top and figure out how many payments she's going to make. 2 years, making 12 payments per year. That's going to be 24 payments in total. Jumping over to Reese's side, it says he makes quarterly deposits into an account that compounds quarterly. So he has 4 payments per year and 4 compounding periods per year. When we look at his total number of deposits to the bank, 2 years, making 4 payments per year, he's going to make 8 in total. Okay, so I've punched those in separately to the TVM solver, and what comes out is and then I click, maybe I'll change my color here, the little button beside here that says solve for future value. So we could solve for any one of these things, but in this particular question, we'll be clicking the solve for future value button. And the answer that comes out is $2,494.29. Okay, so $100 a month is what she was depositing, and by the end of these 2 years, she's up to almost $2,500. Over in Reese's scenario, we type in all those pieces of information. He's got a question mark beside future value, so that's going to be the solve for future value button that you click as well. And his future value result is $2,485.70. The TVM solver, remember, it acts a little bit funny and sometimes doesn't show you that second decimal place unless you click in the cell. Click in the answer cell to see to see all the decimal places. To see all decimal places. Because this is like a money situation, the TVM solver always shows to 2 decimal places. And if it happens to be a case like this one, so I had to click to find the 9 for Hannah. For this one, the TVM solver actually just says 0.7, and I understand that that means 70 cents. Okay, so that last decimal place is a little bit weird in both situations. Okay, so there's their earnings after 2 years, or at least their savings after 2 years. Okay, fresh start. We've got a couple of new scenarios. Ken wants to save $4,000 for a trip when he finishes his college program in 3 years. He's going to invest in a savings account that pays 4.5% interest compounded quarterly. How much does he need to deposit at the end of every 6 months? So there's so much information packed into this scenario. We just need to be careful to pull it all out and use it in the right places. All right, so how about top to bottom this time? For number of payments, N, he's saving for 3 years, making deposits every 6 months. So that'll happen twice per year for 3 years. So every 6 months means he's making 2 payments per year. So I can go fill that one in as well. The interest rate, it said, was 4.5%. The present value, it doesn't mention anything about starting money in his account, like an initial balance, so that's 0. We're trying to look for the regular payment that he needs to make in order to make this happen. And his future value is going to be the goal of $4,000 that he wants for his trip. The last one that I need to fill in is the compounding period, or compounds per year. The question mentions that he uses an account that compounds quarterly, so there will be 4 compounds per year. This time the question mark is beside payment, so we're going to be using the solve for payment button instead. Solve for PMT. And the result that comes out of that one is, it says negative 629.94. This just means he's like giving it away when he makes the deposit. Okay, so every 6 months, he should be putting 630 or so dollars away into this savings account. Next one is a lottery. So a person has just won a lottery that consists of an initial award of 250,000. So an initial award of 250,000. And the rest of their winnings, so they win more than that, the rest of the winnings are invested in an account with all of these details. 6% interest, compounded annually, and they're going to be able to withdraw $100,000, receiving payments of $100,000 every 6 months for 10 years. What is the total value of their lottery winning? Okay, so this one's got a lot of stuff going on as well. There's the initial prize of 250,000, initial or upfront money. And there is the invested amount that's separate from that. And I don't know what that part is. Okay, it's not actually told to us in this question. So I don't know how much they put into the investment account. But I know that they're going to be receiving payments every 6 months for 10 years. 10 years, be collecting payments or receiving payments twice per year, since it says every 6 months. The interest rate was 6%. The present value, the initial amount, I don't know what that is. That's what we're going to try to figure out here. They are setting it up so that they can collect payments of $100,000. So I'm going to make that negative because it's going to come out of their starting balance. So they're going to take out 100,000, take out 100,000 more until they're left with nothing in the savings account. And let's see, it says it compounds annually. So one compounding period per year. With all of that stuff, I noticed that the question mark is attached to the present value. That's the thing we didn't know. So I'd be hitting solve for present value. And I'm going to find out that the present value is $1,493,776.05. So that's the amount that was invested. So they had this initial lump sum of 250,000 and this other huge chunk of lottery winnings that goes directly into the investment account. In total, we can just add those two things together. Whoops, $250,000. And that's like 1.4 million. Adding those two sums of money together, the final or the total award for this lottery was $1,743,776.05. Must be nice. All right, so we've got a couple more scenarios. These ones we've looked at so far, comparing two different savings plans. We've looked at another savings plan, a lottery winning where we're removing money over time from the lottery prize. And then on the back here, we're focusing on a mortgage question. So you've just purchased a house for $525,000. You made a down payment of 10%. The bank offers a mortgage of 2.75% for a 5-year term and an amortization period of 20 years. Determine each of the following. So this format is very similar to the finance mini test. So this will be like another run through of that style of question. For the amount of mortgage, we're going to first have to figure out the down payment. And then we can take that off of the total. Down payment, 10% or 0.1 times 525,000. And that's 52,500. The mortgage amount is the total cost of the house, 525,000. Subtract whatever you are able to afford upfront in your down payment. So doing a subtraction, I find that the answer there is 472,500 that we're going to be stuck borrowing from the bank in the form of a mortgage. So we're going to try to find next the monthly payment. Monthly payment. Just to keep the details on screen there. We're looking at a 20-year amortization, so a 20-year mortgage, not a 25, which is more common, but a 20-year mortgage, and we're making monthly payments for this mortgage. That'll come out to 240 payments in total. The interest rate for the bank is 2.75%. The present value, that's the mortgage amount that you're going to borrow from the bank. So 472,500. Monthly payment, that's what we're going to be trying to find. It's not known yet. So that one you can put a question mark. The future value, so you're going to borrow this big chunk of money from the bank, and eventually it's going to be worth nothing. You'll have paid off the debt. And then these last two have to do with the timing. So payments per year, this was a monthly mortgage payment, so 12 of those a year. And for mortgages, the number of compounds per year is always 2. Semi-annual compounding for all mortgages in Canada. Okay, so even though it's not said in the question, we're going to use a 2 always for that number. If we put that into the TVM solver, the answer that comes out for payment is going to be $2,558.09. It's negative again because you're giving away money every month as you pay off this debt to the bank. So a monthly payment of $2,558,000, whatever, you can see it in red. Next one, the amount paid over the course of the mortgage. So how much money in total are you paying for this house? If the interest rate stays the same, which is definitely an assumption. Interest rates vary every so often, so that's not necessarily going to be true. But based on the current mortgage plan, we would be making this monthly payment of $2,558.09, and we're going to make that payment 240 times. So every month for 20 years. Multiplying those together, we can find that the total amount that we end up actually paying is $613,941.60 on a house that originally cost $525,000. So you can kind of compare those and see how they differ. So that's going to be our next question. It's on the next screen, which is a little bit annoying here. But the next one says, what is the total interest paid at the end of the mortgage? So I'm going to go back here and try to remember these two numbers. The total amount that you pay for this house over the 20 years is $613,941.60. And I'm going to subtract from that the cost of the house. The difference in those two numbers is all the extra interest money that the bank is going to collect. So the interest is going to be that bigger number, $613,941.60. Subtract the house cost. Sorry, not the house cost. That's a mistake in my wording on the previous page. The interest. Oh, yes. I'm actually going to write down here the mortgage amount. So we borrowed $472,500 and ended up paying back $613,000. So this was the borrowed amount, or the mortgage amount, and this was the total paid. If we do that subtraction, the answer I'm getting is $141,441.60. All right, so we've paid an extra $141,000 in interest. Final question here. What is the house worth at the end of the term? So there's just a little piece of vocabulary there. If the appreciation or growth rate is 3.5%. So here's a formula we're going to use that's just practicing some of our exponential skills and trying to make a connection there. So this is like an exponential growth formula. Exponential growth. So it looks something like this from our last video. Original value is A, the 1 plus appreciation rate, that's going to be the base of the power, and the exponent's how long we are letting the house value increase. So I'm just going to plug into that formula. New value equals the original value of the home was $525,000. 1 plus the appreciation rate, so this is 1 plus 3.5%. And the exponent is the number of years. So at the end of the term, I need to look back and figure out what that term was. And it's not the full length of the mortgage, that's the amortization period. The term is how long you've made your deal with the bank for, so only 5 years. And then at the end of 5 years, you might go to the bank and say, my house is worth this much now, I want to remortgage, or make changes then. So we're looking at 5 years for the term. To make this equation usable, I need to change 3.5% to a decimal. And you could type it into your calculator like this, or if you want to do one more simplifying step, that's 1.035 is the simplified base. For the calculator, I always recommend you do the exponent first, like following BEDMAS. Evaluate the power of the exponent first. The answer there is like a big long decimal, 1.187,686,306. So I didn't even write down everything. If you're doing this yourself, you should keep that number on your calculator and then multiply by 525,000. And the final value of this home after 5 years is going to be $623,535.31. So it's grown a good deal over those 5 years. All right, so there's our finance review. There's also some exponent stuff I've thrown in there just because it's related. And that's it. So there's our whole course review, all done in videos. There's practice for each of those topics, and you should be choosing which one you want to ones you want to focus on for our reassessment day.